In Z operating system, virtual storage is very important. Uh, ZOS uses both the real or the central and the auxiliary storage uh, to enable another kind of storage. Yun nga yung virtual storage. In ZOS, each user has access to the uh, virtual storage rather than to the physical storage. This use of virtual storage is the central and unique ability of COS to interact with a large number of users concurrently while processing the largest workload. Uh, Virtual storage means that uh, meaning each running program can assume that it has access to all the storage defined by ZOS architecture addressing scheme. And then the only limit is the number of bits in the storage address. And then in COS uses a series of table mm, to determine whether a page is in or the instruction is in real or in the auxiliary storage and where to find. To find a page or instruction of a program, ZOS checks the table for the virtual address of the page rather than searching through all the physical storage for it. And COS then transfer the page into central storage, as can you see here, or out to the auxiliary storage as needed. This movement of pages between auxiliary storage slot and real storage or central storage frame is what we call paging. Uh, Paging can also take place when ZOS loads an entire program into a virtual storage. COS obtain virtual storage for the user's program and allocate a central storage frame to each page. Each page is then active and subject to normal paging activity. And because of that, most active pages are retained in the central storage or real storage, while the pages that are currently running active might be paged to the auxiliary storage. Uh, the piece of program executing in a virtual storage, moving between real and auxiliary, as I said before. No? To allow this, the Z operating system manage the unit of block in uh, 4 kilobytes. Uh, these 4 kilobytes here, yeah, that's one. That's the at the center we manage the 4 kilobytes. Mm, the block of central storage is the frame, and the block of virtual storage is the page, and the block of the auxiliary storage is uh, the slots. No? A page and frame and a slot uh, are all size in 4 kilobytes. Uh, I have some slide here. Yeah, that. COS uses the segment, the page, and the frame or the region of the tables to keep the track of the storage. The address are translated dynamically, and this process is called dynamic address translation. And then ZOS also uses various storage manager to keep track of all the pages, frame, and slot into the system. For the real storage, ZOS uses the RSM or Real Storage Manager. And it also the same with the auxiliary storage manager. And for the virtual storage, VSM, the virtual storage manager. The RSM keep track on the content of the central storage, and the ASM uses the system page data to keep the track of the auxiliary storage slot, and the VSM responds to the request to obtain and free the virtual storage. COS means that only a piece of a program that currently active need to be in the central storage at processing time. Now, the inactive piece of program are held in the auxiliary storage, and we need an other space to identify that required piece of information. And also, dynamic address translation is used to translate the virtual address and map to different address in a central storage. And kapag nag-exchange na sila. Uh, when a requested address is not in the central storage, a hardware interrupt is signaled in the COS, and then the operating system pages in the required instruction and data to the central storage. When a program is selected for execution, then ZOS bring it into the virtual storage, then divide it into the pages for the execution.